Hi, everyone, and welcome to our lecture video, Introducing Stoichiometry in the Aspect of Limiting Reactants. By the end of today's lecture video, you will be able to identify and quantify the limiting reactant, be able to determine the amount of excess material, and also help create a roadmap to help guide yourself through limiting reactant problems. So we're going to harness your understanding of stoichiometry and unit conversions to be able to identify what reactant might limit our chemical reaction. So what a limiting reactant does is related to the reactant that is utilized or used the most, and that ultimately limits the quantity of how much product is going to be formed. So let's think about making a sandwich. In our example here on the right, we know that we need 2 pieces of bread. When we combine 2 pieces of bread with 3 pieces of meat and 1 piece of cheese, ultimately we form 1 sandwich. But to make 1 sandwich, we need 2 pieces of bread, I need 3 pieces of meat, and I need 1 piece of cheese. But we notice I have 9 pieces of meat overall, which means the maximum amount of sandwiches I can make is ultimately 3, because the amount of meat limits how many sandwiches we can make. We notice all of my meat is used up, but I have some extra amount of cheese and extra amount of bread. But ultimately, I can't make more sandwiches because I don't have enough meat. We're able to say that we have excess bread and excess cheese. So what we're going to be doing today is utilizing stoichiometry to figure out, in an actual chemical reaction, what's our meat in this case, what's going to be our limiting amount of reactant, and what's going to be our excess and how much excess we're going to have left over. What we've seen so far is something called a stoichiometric mixture. And if I have this chemical reaction here with 1 nitrogen gas molecule reacting with 3 hydrogen gas molecules to produce 2 ammonia gas molecules, we notice that in our ammonia, right, for 2 molecules of ammonia to form, I need 1 N2 molecule, and I need 3 H2 molecules as well. I can't just use 1 H2 molecule because I don't have enough hydrogen to make my 2 NH3. If I have a perfect amount of everything, we call that a stoichiometric mixture. So in our example here, I have the perfect amount of hydrogens and the perfect amount of nitrogens to form perfect pairing to form quantities of our product. There's just enough molecules to ensure all of our reactants are paired and used up. We call this a stoichiometric mixture. And so far in this class, this is pretty much what we've seen. We've seen perfect reactions of everything. So a stoichiometric mixture is one that possesses equivalent amounts of reactants that match the numbers in our balanced chemical equation. But we don't always have perfect best case scenario. The presence and quantity of a limiting reactant determines the amount of product formed. If I run out of one of my reactants first, ultimately that limits how much product I'm going to form. And what we're going to spend the rest of this lecture video talking about is how to calculate that limiting reactant and how to figure out how much excess reactant there's going to be as well. So let's talk about it in the context of a practice problem, and then we'll come up with steps to help you achieve and work your way through any and every limiting reactant problem. So we're asked here to consider a reaction in which 25 kilograms of nitrogen is mixed with 5 kilograms of hydrogen to form ammonia. It's asking us how many grams of ammonia will form. And it's also asking how much excess reactant will there be. The first thing that you might be a little bit challenged with is reading a problem like this and saying, Dr. Glicker, I don't know how I'm supposed to figure out I do a limiting reactant. And to identify limiting reactant word problems, you're always going to be asked to figure out how much of a product is formed. How much in this case is how many grams of ammonia will form. And in this case, we're given two quantities of reactants. I'm given 25 kilograms of nitrogen and 5 kilograms of hydrogen. So for a limiting reactant problem, we're always going to be given starting amounts of at least 2 reactants. If you see a starting amount of 2 different quantities or more, that's your indicator, in addition to being asked how many grams of a product form, that's your indicator to figure out, okay, this is going to be a limiting reactant problem, which means I need to ask myself, is H2 or N2 going to run out first? And what we're going to do is utilize stoichiometry to figure out which one of these 2 reactants is going to run out first, aka which one is going to limit how much product forms. So let's go ahead and get started with our step number 1. Our step number 1 is to figure out how many moles of each reactant I have initially. Initially, we're told that we have 25.0 kilograms of nitrogen gas. I need to figure out how many moles that is equivalent to. I can't go from kilograms straight to moles. I have to convert first from 1 kilogram, there's 1,000 grams. So once I convert to grams, I utilize my molar mass of N2, and I say for every 28.02 grams of N2, I have 1 mole of N2, and that leaves us with 892.2 moles of N2 initially. Okay, we just figured out how many moles initially I have of my nitrogen, but I also have to figure out how many moles of my hydrogen I have. If I have 5.0 kilograms of hydrogen, take a moment to yourself and figure out how many moles of hydrogen gas do we have initially. Okay, hopefully you had a moment to challenge yourself and do this stoichiometry. Similar to our step on the left, we're able to say that for every 1 kilogram, I have 1,000 grams. And then for every 2.02 grams, we have 1 mole. As a reminder, in my denominator, I have to put 2.02 grams because I have 2 hydrogen atoms in H2. And when I solve for that, that ultimately tells me that we have 2,475.2 moles of H2 initially. Now, that doesn't tell me any information about my product, right? I can't look at these numbers and make any identifications of what my limiting reactant is. So to work our way towards that, I need to utilize these new numerical amounts of moles of my reactants to figure out how many moles of product would be formed. So what I need to do is I now need to go from moles of N2, I need to figure out how many moles of NH3 that would yield us. When I do that, I plug in 892.2 moles of N2. And we know, because of my molar ratio, for every 1 mole of N2, it produces 2 moles of NH3. So for every 1 mole of N2, it produces 2 moles of NH3. So when I plug that into my calculator, we end up getting that this would produce, if all of 892.2 moles of nitrogen gas react to form ammonia, this would produce 1784 moles of NH3. Okay, so we have that many moles of NH3 that would be produced if all of my nitrogen gas reacts away. Let's do the same thing now for hydrogen gas. Challenge yourself and identify how many moles of ammonia would form if all of my hydrogen gas reacts to form ammonia. So to figure this out, we're able to say that if I have a certain amount of moles of H2, I can figure out how many moles of NH3 form. We know that if I have 2,475.2 moles of H2, utilizing my molar ratio, for 3 moles of H2, I have 2 moles of NH3. And when I plug that into my calculator, we end up getting that this would form 1,650 moles of NH3. So what we just did was figure out if all of each reactant form our product, which one would form the least amount of product? And we compare and we say that if I compare the number 1784 to 1650, 1650 is smaller. That means that is the most amount of NH3 that can form. This is the most NH3 that can form, meaning H2 is our limiting reactant. Here are these answers, and the limiting reactant is associated with the smallest amount of product that can form. That means all of our H2 is going to be used up to form 1650 moles of NH3. So we can't produce the 1700 over here because I'm going to run out of hydrogen before we're able to make all of that. So what we've just been able to do is identify what our limiting reactant is. So to get that written up in our step number 3, the smallest amount of our product produced is from our limiting reactant. We're able to say that our limiting reactant is our H2, and we're able to say that it would produce 1650 moles of NH3. Now, the question, if we go back to the beginning, the question was asking how many grams of ammonia. This is how many moles of ammonia would be produced. So to find out how many grams of ammonia, we would be able to say that for every 1 mole of NH3, we would have 17.04 grams of NH3. When I plug that into my calculator, we get that 2.81 times 10 to the 4th grams of NH3 would be formed. And that's our first main part of our answer. We're asked in our question, how many grams of ammonia are produced? And this is how many grams of ammonia are produced because we identified that our H2 is going to run out. However, we were also asked to calculate the amount of excess, right? We know that if H2 is our limiting, we're able to say that N2 is our excess reactant. So I'm going to have to find out how much N2 is left over now. And to do that, what we're able to do is subtract our excess 3 minus our limiting NH3. So when I plug that in, if all of our nitrogen gas were to form NH3, it would produce 1784 moles of NH3. And if our H2 fully reacts, this would produce 1650 moles of NH3. When I subtract these together, I get this number 134 moles. What this amount of moles represents is the excess 3 that would have formed if 2 fully reacted. which means this amount of NH3 is associated with whatever's left over from our nitrogen. So what we're going to be able to do now is be able to go from 134 moles of NH3, and I'm not interested in the amount of NH3 excess, I'm interested in the amount of N2 excess. So what I'm able to do is say, okay, if I have 2 moles of NH3, we have 1 mole of N2, and I'm asked for grams. So for every 1 mole of N2, we ultimately also have 8.02 grams of N2. So when I plug that into my calculator, we get 1877 grams of excess, or we would be able to say that's 1.877 kilograms of excess, which if we check our problem, we start off with 25 kilograms of nitrogen, of which we have 1.877 kilograms left over. Okay, so now what we're going to be able to do is wrap up this video with our stepwise process to help us answer any and every limiting reactant problem. So our steps to find our limiting reactant. The first is to write out our balanced chemical equation. Sometimes you're given it, sometimes you're not. If you're not, then you'll have to write it. But if you are, we just move on to step 2. Next is to determine the amount of moles of reactants initially given. I need to figure out how many moles of each reactant I have, because in step number 3, once I go from there, I can go from grams of reactants to moles of reactants, because in step number 3, we can calculate the total amount of moles of product that would be formed if all of those reactants produced product. How that would look, we would say that the moles of each reactant, we would want to convert to our moles of the same product. In this case, I converted to moles of ammonia for both. Then we're able to say that the reactant that forms fewer moles of our product will limit how much product is actually formed, and we identify that as our limiting reactant. And if you're asked to determine how many grams of product will actually form, we would go from moles of our limiting reactant to moles of our product to grams of our product, and that would get us our final answer. So stay tuned for our next class, where we are going to be doing a whole bunch more practice to help us get a further and deeper understanding in limiting reactants. Bye, everyone.